Hi everyone, in this video we are going to solve one more problem. The problem name is minimum distance between BST nodes and the problem number is 783. Alright, so first of all we are going to see about this problem. We will see what this problem says. After that we are going to move to the logic part. We are going to see how we can solve this particular problem. And after that we are going to see the implementation part. We are going to implement our logic in C++, Java and Python programming language. Alright, so now let's see this problem. Given the root of a binary search tree BST, return the minimum difference between the values of any two different nodes in the tree. So we have to return the minimum difference by taking any two different nodes from a tree. So let's take this example, then try to understand this problem, what this problem says. So we are given the 4, then 2, then 6, then 1, then 3, right? Now guys, we have to take two different nodes from this particular tree, such that the difference between them should be the minimum from all other possible pair of two different nodes. So if I take a 4, 6, I took these two different nodes and I'm getting a difference nothing but 6 minus 4, 2, right? So I quoted two minimum difference. But this is not a minimum difference. If I take a pair 2, 3, then it is giving a minimum difference 1, right? If I take a pair 4, 3, that also giving a minimum difference 1. So I can say the minimum difference which I'm getting is nothing but 1. So the possible minimum difference which I can get from this binary search tree is gonna be nothing but 1. I hope this much is clear to you. We have to take just two different nodes such that the difference should be that the difference between that two different nodes should be the minimum difference from all other possible nodes. And we have to return that minimum possible difference, right? Now guys, let's see the logic part. I hope you are clear with this particular problem, what this problem says. Now how we can solve this particular problem? What is the approach? So let me write a logic and let me take a different example because this first example is very, I would say a very basic example. Everyone can understand from there. So if I take this example, 90 is a root node and it has a left node that is nothing but 69, right node 89 and left node 49 and right node 52. Alright guys, so this is the BST which we are given with. Now we have to return the minimum possible difference from n two different nodes, right? So now guys, the brute force approach, I would say just come up with a brute force approach and tell me what is the approach you are having right now. So I will say forget about time complexity, whether your solution are going to give n cube, n log n. Initially forget about time complexity and space complexity, right? Just tell me, are you able to come up with a solution which can solve this particular problem? Are you able to solve this particular problem? Forget about it will get accepted in LeetCode or not. Are you able to solve the problem? So the brute force approach which I am coming it right now is nothing but I'm going to take in an array all these possible values, which are values given in this array tree, right? So I have 90, then 69, 49, 89, and 52, right? So I stored all this value in my array. If you are using a Java, then array list. If you are using a C++, then vector. You can take any data structure which you want, right? Now what I am going to do, I'm going to sort it. So I'm going to sort it. So let's sort this particular array. So I can say 49 will come at the front, then 52, then 69, then 89, then 90. I hope this much is clear to you. Now once we sort this particular array, now what we can do, we can take a particular global variable that is going to be result, and by default it is had 9 10 is to 9 value. Fine. Now what we can do, we can say guys this is a result which has 10 is to 9 value. We can traverse from this first index. Alright, so I'm going to start from a traversing from first index. I can say just subtract this particular value from the last index value. So that is 49, right? 52 minus 49 nothing but 3. And you can see that 3 is nothing but smaller than result. So update our result. Then we have nothing but value 69. We'll move to ahead and we'll get a value 69. It is going to subtract it by the last index that is 52. So 69 minus 52 is nothing but 17, which is greater than result. No need to update it. Then move ahead 89. 89 minus 69 20. Again greater than result. Don't update it. Then 90. 90 minus 89 1. Yeah, it is smaller than result. So update it. We are getting result 1. I hope now once we completed this traversal, we can return this result and this is our optimal answer. Means we can say correct answer, right? So this is a brute force approach which is going to take a big of n log n time complexity and space complexity is big of n because we are using an array, right? So n is nothing but number of nodes which we are having in this particular tree. So this was the problem. I would say this is a brute force approach. Now guys think about this, that this is a BST, right? We are given the BST. But this solution or this approach can be solved if we are given with an array tree. Means a tree, a node can have n number of children. What we have to do, we have to store in an array and sort it and do the same operation, traverse it and update our result, right? If this was a binary tree, also this approach gonna work. Then what is the specialty about BST? Why they've given BST? Just think about this. So let me move all these things. So guys, the thing is that binary search tree we have root node. The left side of root is always be less than the root node and right side will always be greater than the root node, right? So this was the logic in BST. So now guys, if you know a little bit about BST, then we have three kind. If you know a little bit about tree only, not BST, then we have three travels, right? In order, pre-order, and post-order. And if we talk about especially BST, then you know that in order will always going to give a sorted order, right? So we don't need to store in an array. We don't need to do a sorting. If we use a in order, traversal in binary SSD, then we will definitely gonna get a sorted order. I have this much clear to you. So now guys, what we are going to do, we are not going to store also in an array. Why? We are going to use instead of that a variable. And I'm not going to tell you how, because we are going to do dry run and then we will understand this, right? So I'm going to remove all these things and we are going to see the dry run of our logic, what I'm going to do, and you will definitely get a better idea from there. All right. So what I'm going to say, I'm going to have one variable that is data. Initially it will have -1 because the value in a node will always be greater than 0 or equal to 0, right? So I can take a value which is not present in our, we can say, our node, right, or in a tree, right? After that I have a result variable which is by default 10 to 9 is a maximum value. Fine. And they have also told that the max this tree BST will have at least 2 nodes, right? So we don't need to take care about that 10 to 9 as well. All right, so we are going to do in order traversals. So in order, we are going to move first of all left side, right? Then we'll come to root value, fine, and we'll move to then right side. I hope this is the in order traversal, you know, right? Now guys, think about this. We are going to move to the first of all left side. From 90 we'll come to 69, then 49, then we'll come to left side, right? All right, so we can say left side is nothing but null. All right, then it will move to the root. I hope this much is clear to you. Now 49, now focus over here. 49 is a root, right? So it is going to print this particular value if you are using a traversal, but here we are not going to print it. We are going to say, just check, is there any value which you have already gone through? No, because data is still -1, right? So if you haven't gone through, you don't need to update your result, right? Fine. So but before moving ahead, we are going to update data with this latest value, that is 49. Fine. Now we'll come to right side for this particular root node, right? Because we have seen the left side of this root node, we have seen the root also. Now move to the right side, that is 52. Fine. So you can see that for 52, we are going to check the left side, that is nothing. So it's going to come to the root 52. And instead of printing 52, we are going to check whether is there any previous value which we have gone through. You can see data has 49. That means it is not a -1. That means we have gone through a last value, right? So we are going to say subtract this value, root value, with this data. So that is nothing but 3. So 3 is a smaller than result, so update your result. Now before moving ahead, we are going to update the data with the latest value, that is 52. All right. Now guys, you can see that this 69 has completed this left child, right? So it will come to the root 69. So while printing 69, it will gonna see whether the last value data is present. It is not a -1, that means 52, right? So it is present. So we're gonna subtract 69 minus 52 and we're gonna see that that is 17, but we are not gonna update it, right? Because 17 is greater than the result, right? So we will not gonna update. But we will move ahead, and before moving ahead, we are gonna update our data. We are gonna put data the latest value, right? It will go to 89, and 89 it will going to see the 69 is the last value. So subtract from that and we will get a 20. So 20 is again greater than 3. We are going to update it. We'll move ahead to 90, right? Because 90 has completed this left side. Now guys, is instead of printing 90, we are going to check, is there a last value? Yes, there is a last value which is present, 89. We have to update that as well, right? So now we are going to subtract 90 minus 89, that is nothing but 1, right? And here we can see 1 is smaller than result. So update your result. So we are going to update our result and we are going to say result is 1, right? Now we'll move to the right side of 90, that is nothing, null. And we can see that we have completed our traversal, right? So once we have completed our traversal, we can say result is going to have the minimum possible difference, that is 1. So we are going to return 1. So I hope now you understood that we have to just use an in-order traversals and we have to print whatever the result value once we have completed the in-order traversals. So let's see how we can implement this particular logic, how we can implement in C++, Java and Python programming language. So let's move to the logic part and see how we can implement this particular solution. So what we can do, we can say we are going to use a in-order traversal, right? So what we can do, we can define a function. Inside of Python, you can define a nested function as well. So we are going to say define, and I'm going to give a function name solve. And here what I'm going to do, I'm going to say root, right? And here I can say if not root, then you can return, right? Because we are not going to do anything, but we have to define two variables, that is result and data. So initially result is going to be nothing but guys 10 is to 9, or we can say in a Python float of infinity, which is a maximum value. And data is going to be nothing but I told you that -1, right? All right. So first of all, what we are going to do, we are going to say solve the left side, root dot left, and then solve the right side. This is what nothing but I know the task, right? Before that, in between, we have to print the root. But instead of printing this root, what we can do, we can say that compare with the last value. So I'm going to say if data is not a -1, right? Then what you can do, you can say just update your result. Result should be the minimum, either result or root dot value minus data, right? If it is not a -1, if it is the case, then only you can do. If it is not, if it is equal to -1, no need to do anything, right? So after that, we are going to say data should have the latest value. So root dot value should be stored in data. So this is the thing what we have to do. Now once we have done this, we can say call this function sol.root and you can return this particular result. If we run this code and try to see whether we got a right output or not, let's see that. So I got an error because it is data is a global local variable, so we have to import non-local data and result. Now we can run this particular code because now we can access this data and result variable inside this nested function. Now it should give us accepted. Let's see that. So you can see that both the test cases are passed. So let's try to submit this code. And you can see guys, it's successfully accepted, right? So now we have successfully submitted our solution in Python. Let's try to solve this in C++. I believe it is not much difference, right? We have to just take two global variable. So I'm going to take one is result, which is I'm going to take 10 is to power let's say 9, or let's take it a 6 because at max value I can see that then nothing but 10 is to power 5, right? All right, and int data is going to be a -1, and I'm going to define a function which is nothing but void sol, and which is going to take a 3D node root, and let me write root. Fine. And if node is root is null, if root is null ptr, then what we can do, we can say return. And if it is not the case, then solve for left side. So root dot left, and let me write left. And then after that you have to check if data is equal to -1, then don't need to do anything. But if it is not a -1, then we can say update your result. So we can say result is going to store minimum of result comma root value minus data. And after that insert a value, latest value inside the data, right? So we can say data is going to store root dot val. And now solve for right side. And I can't use a dot here, I have to use this greater sign. All right, now guys, once we have done this, we can call this particular function. So we can say sol root and we can return our result. I hope this much is clear to you. Now let's try to run this code and see whether it's getting accepted or not. You can see that it accepted. Now let's try to submit this code. And this one also successfully submitted, right? Now the last part is nothing but Java, right? So let's write a code in Java. And here again guys, I'm going to define two variables. The first variable I'm going to say int result, and it is going to be an integer dot, let me write integer dot, we can say a max value, right? Okay, so let's write max value. Fine. And int data is going to be a -1. Again I'm going to say public void sol, and it is going to take 3 node root, and we can say if root is null, then what we can do, we can say return. But if it is not the case, then we have to check if data is not equal to -1, then we can say guys our result should be updated, right? So result is going to be mat.min result comma root dot val minus, we can say data, right? And after that update latest value inside the data. So root dot val is going to be in data, right? After that solve for right side. So we can say solve for right side, and I just now remember that I haven't called for left side, right? So I have to call for left side. So I can say solve root dot left, and then we have to call for root dot right. I believe guys you are getting it what I am doing here. And after that I have to call this particular function. So I can say call this solve function with the root and return our result. Let's run this code and see whether it's getting accepted or not. It is an easy program, I guess, right? It is an easy program as well. So I got an error. I haven't used a semicolon here. Semicolon is the biggest error which I got. One more error is nothing but integer dot max value. So I'm getting an error here. It says that cannot find a symbol. So guys, let's keep it here nothing but 10 is to power 6, right? 2, 4 and 6. All right, so let's try to run this code now. And if you're getting, if you know why I got an error, just tell me, right? And here also root double equal to, why I'm getting this much error in Java. Java is a really hard language. All right, it got accepted, right? So let's try to submit this code, and I have to check out also that why I was getting that integer dot max value. And here guys also you can see that it's successfully accepted, right? So Java code also accepted, Python also accepted, and C++ also accepted. I believe you understood the logic part as well, how we can solve this particular problem, why I use a in order traversals, why not any period or post order traversals. Yeah, definitely we can use a post order as well. So if you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.